Hi guys, RLA Jack with my first video in the Matrices little series. So we're done with the very basics of MATLAB, and now I'm going to show you an entirely new type of data. So previously in the past, we had variables just equal to like numbers. Like I can set the value of a to be 6. But there's sometimes some cases where it's very useful for a variable to store multiple numbers, such as whenever your data has like some sort of structure, like a table of values, or whenever your data needs to be manipulated in certain ways. You can do it a lot easier with a matrix, because say we had to store every single number we wanted to know as a single variable separately. That would end up getting very tedious very quickly, and it would be very hard to program systematically with that. So what we have is the matrix. So there are a few ways, or a few types of things that fall as matrices. So technically this is a 1-by-1 matrix, because namely in the workspace, if you actually do whos, you'll see that this variable a is 1-by-1, and it has 8 bytes, which is just how much space it takes up on your computer, and that's due to it being something called a double. And a double is just saying that it is stored with double precision. That's 8 bytes of information for each number, and it turns out matrices are also doubles. So this double right here is just, it's just a number, but it technically is a 1-by-1 matrix. Another example of a matrix, let's call B, is just equal to this blank thing. So if I do whos again, you can notice that B is a 0-by-0 matrix, and it's also a double. So suppose you have another matrix C. It can be perhaps a vector. So the way you declare a matrix is by using brackets. So you have an open bracket and a closed bracket, like I had with that. This one's 0-by-0 because it contains 0 rows and 0 columns. But if you create a matrix with, say, 1 row and 3 columns, like C equals 1, 2, 3, that is a 1-by-3 matrix because it has 1 row and 3 columns, RC, like the COLA. The old instructor for 210 had a thing about that. But this is what you would call a row vector. And if you want a column vector, instead of separating your values with commas, you can separate with semicolons. Say you have D, which could be like equal to 3, semicolon 3.4, semicolon 3.7. And it's a column. Do whos again. Notice that this one, C, is 1-by-3, and the D is 3-by-1. This is because it's the number of rows and then the number of columns. A column vector has 3 rows and 1 column. And then finally, we can do a whole matrix. Let's call it E. I'm just going to do my favorite matrix, which is 1, 2, 3, 4, 5, 6, because it's nice and easy to type, and it's 2-by-3. It's not square. So if I do whos again, you can notice that E is 2-by-3. These are all doubles here. They're all double precision floating point numbers. They just have different sizes, different numbers of elements in them. And the rules for vectors are the same as the rules for matrices. Okay, so this might be a way that we store information. So let's go through a few things and try and look at the information in E and edit the information in E. So we have E there. It's currently that. Let's say that we now have E and we want to just get one value from E. So we can use parentheses. Now again, same parentheses as a function, so don't be naming your functions and matrices the same thing. That's always sort of a danger. in MATLAB. Other languages use brackets, and those are a little bit nicer. But MATLAB uses parentheses for both. And then you can do e of 2 comma 2, and that'll ask for what is the value of the second row and the second column in matrix E. And surely enough, that'll give you that 5 that's right there. Do e of 2 comma 3. You could have guessed what that was. E of 1 comma 3. Guess what that was. Again, if you ever learned another programming language, MATLAB is a language where you look at rows and columns as if the first row and the first column were starting with 1 rather than 0. If you've ever done, like, Python stuff or Java stuff. But this follows in the tradition of Fortran, which starts with 1. You can also ask for multiple values, like a range in a matrix. So you can ask for the first through second row. That colon says first through second, and the first through second columns. Surely enough, it'll take that little excerpt out of your matrix E. And you can also ask for the first through second columns and the second through third columns, or you can do just this, second row and second through third columns. Any of these are possible. This is how you take excerpts from a matrix. You can also, if you index it with just a vector, like you can ask for columns 1 or rows 1 and 2, and then columns 1 and 3, it will give you that. It turns out that this 1 colon 2 thing is exactly the same as this vector, 1 comma 2. So you can also edit the individual numbers inside of E. Again, by setting these equal or assigning something to this variable or part of a variable, you can edit E itself. So you can do like E of 1 comma 3 is equal to 7. Now when you display E, you get that. Or you can do like E of 1 colon 2 comma 1 is equal to the column vector, which has the same dimensions, 2 rows, 1 column, maybe 8 semicolon 9. Surely enough, it'll replace that 1 4 with an 8 9. That's really one more thing. You can just set it equal to 8 or a single number, and then I'll paste all of the numbers in here with that single number. But you end up not using that too much. Okay, so that's it for the basics of storage in matrices. In the next video, I will look at doing operations on them and also building them using special functions. Actually, I think I'm just going to do building in a single video and then move on to operations. Okay, so that's it for right now. Bye.